This video will discuss chapter 10.4, Pythagorean Theorem. Keep in mind this theorem is named after the person who developed it, Pythagoras. And so Pythagoras' theory, or theorem, now named the Pythagorean Theorem, is this idea that in right triangles, and this only works in right triangles, if I take the square of one leg and the square of the other leg and I add them together, so in other words, the sum of the squares of the legs will equal the square of the hypotenuse. Okay, and so this word is probably a good one. Hypotenuse. Hypotenuse, that is the leg that is opposite the right angle. It is the longest leg of a right triangle. Okay, and if I go the sum of the two legs of the triangle, sum of the squares of the two legs of the triangle equal the square of the hypotenuse. Okay, this is probably a good thing to write down in your notes, as we're going to be using it a lot in this video and then in class. Alright, so the first idea is, the first type of problem you might see is one like this. So you got a right triangle, 8 millimeters here, 15 millimeters here, and I want to find what is the length of this. Keep in mind that is the hypotenuse, so this would be a squared plus b squared equals c squared. So in other words, I'm going to go 8 squared plus 15 squared equals c squared. Okay, 8 squared is, sorry, I'm typing in the next number. 8 squared is 64. 15 squared, I had to make sure I was right on that, is 225. When I add those together, you get 289. Right? And then what you need to do is take the square root of 289. And that is going to, so now I've got, I'm sorry, I shouldn't have done it that way. I apologize. It should be c squared. Right, we'll keep it as an algebra problem. Then when I simplify this, this is 289 equals c squared. This is probably a better way of looking at it. Then what I need to do is I need to take the square root of this side and the square root of this side. Right? When I take the square root of c squared, I end up with c. The square root of 289 is 17. So this ends up being 17 millimeters. All right, so that's one way that you might use the Pythagorean theorem. Another way is, how would I find the diagonal of this rectangle? And so if this is a rectangle, 30 feet on one leg and 60 feet on the other, question is, what is the length of the diagonal? The diagonal happens to be the hypotenuse, as it is opposite the right angle. Okay, so keep in mind that means that this leg of this triangle, so we're looking at this triangle here, right? The leg of this triangle, the hypotenuse of this triangle is going to have to be the longest leg, which means my answer has to be greater than 60. So keep that in mind as we're solving this. So this is going to be 30 squared plus 60 squared equals, and we'll call it c squared. All right, so 30 squared is 900. Let's just make sure I'm... And 60 squared is 3600. And so when I add those two together, I end up with 4,500. Oh, sorry, this should be c squared. I almost made the same mistake again. So I got 4,500 equals c squared. Now, what I need to do is find the square root of 4,500. I will remind you that at times it may not necessarily come out to a nice, pretty number, and this is going to be one of those examples. So when I do the square root, I get c here. And this is going to be, and I'm going to write a bunch of these numbers down just so you can see. When I do the square root of 4,500, I get 67.0820039, and then it kind of keeps going. All right, so I want you to see that what I'm going to end up doing is rounding. And so what I'm going to do is round this to the nearest tenth. That's the tenths place, which means I need to use this number to help me determine how I should round it. This 8 tells me that I should round up. So this is going to be approximately, and you'll notice I'll do the squiggly equal sign, 67.1 feet. right? And so I rounded this up because of the 8, so this becomes 67.1. All right, so that's how I might use it to find the diagonal of a rectangle. And the last way you might see it is they're going to give you 3 measures of the sides of a triangle. And the question is this a right triangle? In order for it to be a right triangle, then this would have to be true. If this is not true, if a squared plus b squared does not equal c squared, then it is not a right triangle. Now, in this particular example, it works out, but keep in mind it does not necessarily have to be a, b, and c. So they could have written this in different order and gone, let's just reverse it, say it was 10 centimeters, 8 centimeters, 6 centimeters. Remember that the hypotenuse has to be the longest leg. So no matter what order they write these numbers in, this is always going to be c squared. Whichever is the largest number has to be c squared. A and b really don't matter. A lot of times people get really fixated on making a the shortest, b the middle, and c the hypotenuse. The only one that really matters is the hypotenuse. The order in which you put these don't matter. And a lot of that is because if you think about the commutative property, it doesn't matter which one of these you put first. B squared plus a squared is the same as a squared plus b squared. So either way, you're going to be okay as long as you get the longest leg as the hypotenuse. So this would be, and we'll keep it as a squared plus b squared equals c squared. So this would be 36 plus 64 equals 100. Okay, and I'll kind of take it up here. 36 plus 64 is 100 equals 100. If it's true, if these two actually do end up being equal, then yes, this is a right triangle. Right? So I'm just going to draw this as a right triangle. Very good-looking triangle. And so then this one, I'm going to go a squared plus b squared equals c squared. So this is 16 plus 25 equals 36. 16 plus 25 is 41, does not equal 36. So you can either write no, you can write this is not a right triangle, however it is that you want to denote that this is not a right triangle. But since these are not equal, then this is not a right triangle. Right? So in order for it to be a right triangle, a squared plus b squared would have to equal c squared. All right, that's all I got for you on the Pythagorean Theorem. Don't forget to bring your notes from this video to class. Thanks very much for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.